A very good morning to all of you. Welcome back to your maths class. Today, we are again back with chapter number 3, Factors and Multiples. In our previous classes, we have covered some topics from this chapter, which were factors, properties of factors, and methods to find the factors, which were multiplication and division. Then prime numbers, composite numbers, twin prime, and prime factorization by two methods, which were factor tree method and division method. Today we are going to learn a new topic, that is HCF. So what is HCF? First of all, let us know what does HCF stands for. So HCF stands for highest common factor. I repeat again, it is highest common factor, which explains about itself just by its name. That is highest common factor. So we can write the definition of HCF as HCF of two or more numbers is the greatest number that is a factor of all given numbers. Let's understand it with an example. Find the factors of 15 and 30. So we have already learned how to find factors. Here we'll find out the factors of 15. And these are the factors of 15. 1, 3, 5 and 15. These are all the possible factors of 15. Now factors of 30. 1, 2, 3, 5, 6, 10, 15 and 30. These are all the possible factors of 30. What we have to do now is to find the common factors between these. So the common factors of 15 and 30 are 1, 3, 5 and 15. Among all these common factors, we can easily find out that 15 is the highest common factor. So the HCF of 15 and 30 will be 15. Properties of HCF. The first property says that HCF of a given number cannot be greater than itself. It means if we are finding out the HCF of any particular number, it will never be greater than that number. Second property of HCF says that if one number is the factor of another number, the smaller number is the HCF, which means that if we are finding out HCF of any two numbers and any of those number is the factor of another number, so the smaller number will be the HCF. The third property of HCF says that if HCF of two numbers is 1, they are called as coprime, which means that if we are finding out HCF of any two numbers and its answer is 1, then both the numbers will be called as coprime. Fourth property of HCF says that consecutive numbers are always coprime, which means that if we are finding out HCF of any two consecutive numbers means in a series, their HCF will always be 1. Now let's study the methods. So there are two methods of finding HCF. The first one is prime factorization method and the another method is division method. In prime factorization method, we split the numbers in their least factors. Let's try to understand both these methods with an example, which is find the HCF of 24 and 36. So let's start with prime factorization. First of all, let us find out the prime factors of 24. So let's split 24. As 24 is the even number, which is very clear, so it means it will be divisible by 2 and 2 is a prime number. So let's split 24 into 2 multiplied by 12. it will give us 24. Now again we got 2 as our least prime, but 12 is not least prime, so we will again split 12 further, which will become now 2 into 2 into 6. Again we can split 6, so 2 into 2 into 2 into 3. Now we cannot split any number anymore. We have got all the least prime numbers here, so we will stop it. And the numbers which we have got are 2 into 2 into 2 into 3 is equal to 24. These are the factors of 24. Now in the same manner we will find the factors of 36 also. So 36 is equal to 2 into 18. We can split 18 again. So 2 into 2 into 9. Again we can split 9. So 2 into 2 into 3 into 3. Since we have got the prime factors, what we'll do now, we'll try to find out all the common factors between the factors of 24 and 36. So the first number is 2, then 2, and then 3. So it will become 2 into 2 into 3. After multiplying all these numbers together, we'll get the answer as 12. So the HCF will be 12. Let's try the second method, that is division method. In this method, we have to divide the larger number by the smaller number. So we will divide 36 by 24. After dividing 36 by 24, we got 12 as remainder. So 24 ones are 24 and we'll get the remainder as 12. As you all know that 24 is the divisor, 36 is the dividend, 1 is the quotient, and 12 is our remainder here. But to find HCF, what we do, the remainder left now becomes the divisor and the original divisor now becomes the dividend. We need to continue till we get the remainder as 0. Now we have got 24 as our new dividend and 12 as the divisor. So 12 twos are 24 and we got the remainder as 0. Now we have got 0, which was our condition that we have to continue it till we get the remainder as 0. Now we'll stop this division here only because we have got 0 in the last. After completing the division, whatever is our last divisor, it will be our HCF. So here we have got 12 as our last divisor. So 12 is the HCF of 24 and 36. Let's solve one more example. Find the HCF of 25 and 50. First, let's solve this by prime factorization method. So we'll find out the factors of 25, and here we got 5 into 5 and we cannot further split any number among these. Now we have to split 50. So 50 will be split into 2 into 25. Here we got 25 which we can again split. So 2 into 5 into 5. Now we got the prime numbers here which we can't split anymore. Now what we have to do, we have to find out the common factors among these. So common factors between the factors of 25 and 50 are 5 and 5. Common factors is equal to 5 multiplied by 5. Therefore the HCF will be 25 because 5 multiplied by 5 gives us 25. Let's try to solve this question by division method. So 50 divided by 25. 25 twos are 50. We got 0. We cannot split it further. So the last divisor 25 is the HCF. If you remember, we just studied the properties of HCF, where the property number 2 said that if one number is a factor of another number, the smallest number is the HCF. Here you can see that 25 is the factor of 50, and among 25 and 50, 25 is the smaller one. Therefore, we can write directly that 25 is the HCF of 25 and 50. Now, let's move forward and try to solve some exercise questions to understand HCF in much better way. So, from exercise number 3, question number 1, B, the question is find the HCF of 15 and 30 by prime factorization method. So, let's try to find out the factors of 15. 15 is equal to 3 into 5. We cannot split any of these numbers anymore. Now let's try to find out the factors of 30. So 30 is an even number. So 2 into 15 is equal to 30. Here we can split 15 again. So 2 into 3 into 5 is equal to 30. Now we cannot split any number anymore. Therefore, the factors of 30 are 2 into 3 into 5, and factors of 15 are 3 into 5. Now we have to find the common factors between these. So the common factor between these two numbers are 3 and 5. So 3 multiplied by 5 is equal to 15, which is our HCF. Exercise number 3, question number 1, part C. Find the HCF of 24, 32 and 40. Let's use the same method. First of all, let's try to find out the factors of each of these numbers. So the factors of 24 are 2 into 2 into 2 into 3. The factors of 32 are 2 into 2 into 2 into 2 into 2. And factors of 40 are 2 into 2 into 2 into 5. Now let's try to find out the common factors between these. So the common factors are 2 into 2 into 2. Therefore, the HCF will be 2 into 2 is equal to 4 and 4 into 2 is equal to 8. HCF will be 8. Let's try one more question. Exercise 3, question number 2, part B. Find the HCF of 264, 384 and 842 by long division method. Here you can see that these numbers are large, and we also have to find it out by long division method. So don't be afraid of it. We can do very easily. So what we need to do first is that we have to find HCF of any two of these numbers. So let's do it in a series. First, let us find out the HCF of 264 and 384. So here we are dividing 384 by 264. 264 into 1 gives us 264, and we get the remainder as 120. Now 120 became our divisor and 264 became dividend. Let's divide it further. Now 264 divided by 120, 2 times 120 multiplied by 2 will give us 240. Now after dividing it further, we'll get the remainder as 24. Again 120 will become our dividend and 24 will become divisor, and we'll divide it further, and here we got the remainder as 0, which means we have completed this division. So the last divisor is our HCF, which is 24. But here 24 is the HCF of 264 and 384 only. We still need to find the HCF of the third number. So now we'll divide 842 by the HCF of the previous two numbers. So 842 divided by 24 is equal to 24 multiplied by 3 gives us 72. Remainder 12 and 2 came from the next place. 24 into 5 gives us 120. Now we got the remainder as 2. Our remainder 2 will become the divisor and 24 will become the dividend. So 2 multiplied by 1 is equal to 2 and we got the remainder 0. 4 came from the next place. Now 2 multiplied by 2 is equal to 4 and we got the remainder as 0. It means we have completed the division here. And the last divisor, which is 2, is our HCF. We got the HCF as 2. I hope you have understood both the methods very nicely now. Here are some questions which you can try by yourself to improve your skills and to understand HCF. Thank you. See you in the next video.